Welcome back to Sum and Difference Identities. We're now going to write tangent of sine inverse of x plus cosine inverse of y as an algebraic expression in x and y only. Before you do anything too drastic, I want you to notice right here it says no need to reduce final answer. And I say that because when you see what it's going to look like when we're done, you will be very happy that we do not need to reduce the final answer. Let's break our page into two parts. First, remembering that sine inverse of x is an angle. We'll call it theta sub 1. And cosine inverse of y is like theta sub 2. Remember that if we have sine of theta sub 1 equaling x, then if we impose the arc sine or sine inverse on both sides, we will get theta sub 1 is equal to sine inverse of x. So we can take this statement here and sketch a triangle. This should be familiar because we worked this out in a previous section on how to state a generic relationship between x and y. If I know that sine of theta is equal to x, then I can say that it is equivalent to x over 1, and sine of theta is opposite over hypotenuse. That means my opposite side of theta sub 1 is x, and my hypotenuse is 1. If I want to find the unknown side here, I can state this as 1 is equal to x squared plus the unknown side squared. So if I subtract x squared from one side, I will get the unknown squared. This means that the side that we don't know is equal to 1 minus x squared, and now I have all my sides. Now let's work on the other one. The other one is cosine of theta sub 2 is equal to y, which means my y could be over 1. And if I draw my relationship with the triangle, theta sub 2 is going to be adjacent over hypotenuse because it's cosine. So the adjacent side is y and the hypotenuse is still 1. That means that my unknown side is equal to y squared plus unknown side squared equals 1. Therefore, the unknown side will be the square root of 1 minus y squared. You really need to try and do this on your own. In fact, maybe even erase your page right now, pause the video, and see if you can figure out why this side here is the square root of 1 minus y squared. It's not always intuitive the first few times you see this. Now I'm going to erase my calculation here. I have my 3 sides, all with relationship to y. And now I can find any trig identity relationship between the sides, or ratios, based on all sides being known. They're generic, but they're known. Now I'm going to rewrite my tangent as tangent of theta sub 1 plus theta sub 2. And I have an identity for the sum of two angles for tangent. It's tangent of theta sub 1 plus tangent of theta sub 2 all over 1 minus tangent of theta sub 1 times tangent of theta sub 2. And now, this is where I said, I warned you, this was going to be so nice so we don't have to simplify it. tangent of theta sub 1 is opposite over adjacent, which means I'll be taking x and then 1, the square root of 1 minus x squared for my tangent of theta sub 1. So opposite over adjacent, x over square root of 1 minus x squared plus tangent of theta sub 2, that is opposite over adjacent again, which is the square root of 1 minus y squared, all divided by y. In the denominator, I have 1 minus tangent of theta sub 1, which I'll replace with x, over the square root of 1 minus x squared, times tangent of theta sub 2, which is the square root of 1 minus y squared, all divided by y. This incredibly messy fraction is the equivalent of tangent of theta 1 plus theta sub 2, and this is a sum of two generic angles. I think that if you can figure out how to do this confidently, you will be so far ahead in calculus, because in calculus you have to manipulate trig functions all the time so that you can integrate them or take the derivatives. And so practice this. It will definitely be on a test sooner or later. And if you have any questions, make sure that you ask them and maybe even rewatch this section. Now let's try to evaluate cosine of alpha minus beta, the two angles alpha and beta, where cosine of alpha is equal to negative 12 over 13, with alpha in quadrant 2 and tangent of beta equal to 6/5 with beta in quadrant 1. I know that I have two angles alpha and beta is being subtracted from alpha. I know that there is an identity for cosine of alpha minus beta, which is, remember, cosine doesn't play well with others, so it's cosine alpha cosine beta, and since the sign is a minus, we'll call it a plus here, and then sine alpha times sine beta. That's our identity. Now we're going to sketch some triangles so we can figure out what quadrant everything is in, and we can move from there. In the cosine of alpha is equal to negative 12 over 13 with alpha in quadrant 2. So we're going to sketch this over here in quadrant 2. Cosine of alpha in the second quadrant will be adjacent over hypotenuse, and so adjacent is 12, hypotenuse is 13, and we need a negative sign, so clearly that's going to be attached to the 12, not the 13. We need to find this side over here that we don't know. That's going to be 13, the square root of 13 squared minus negative 12 squared. That gives me the square root of 25, or just 5 here. And then the other graph we need to sketch is tangent of beta. Tangent of beta is in quadrant 1. And I know that tangent is opposite over adjacent. That means 6 is the side opposite and 5 is the side adjacent. We can find the hypotenuse by taking the square root of 5 squared plus 6 squared, which gives me a hypotenuse of 61. The square root of 61. That doesn't come out very nice, does it? It's okay, we'll still make it work. The cosine of alpha minus beta is equal to the cosine of alpha, that's negative 12/13, times cosine of beta, which is adjacent over hypotenuse again, so 5 over the square root of 61, plus the sine of alpha, so that's 5 opposite over hypotenuse 13, times the sine of beta, opposite over hypotenuse, which gives me 6 over the square root of 61. And now I just calculate that. The first one will be negative 60 over 13 root 61 plus 5 times 6 is 30 over 13 times root 61. Notice that the denominators match, which is convenient. I'll take anything at this point. That gives me negative 60 plus 30 all over 13 root 61. If I add negative 60 and 30 together, I get negative 30 over 13 root 61. Now from here, if I rationalize the denominator, I'll have negative 30 root 61 all over 13 times 61. And that doesn't really make it any better. I would take either one of these answers as the exact value of cosine of alpha minus beta.